Is it clear, guys? Accuracy, precision and errors? Yes. Now let's move on to the next topic, that is types of error. Types of error. Yes. And here we discuss three types of error. Here we are going to discuss three types of error, and they are systematic error, random error and least count error. Yes. Even though here I am discussing least count error as a separate type of error, we can say least count error is actually both a systematic error and random error. Least count error has properties or features of systematic error, and it also has the features of random error. Yes. Now let's start with the first type of error, systematic error. Yes. What is systematic error? So systematic errors are those errors. Which always occur in the same direction, and sometimes by same amount while doing measurements or while measuring a particular physical quantity. Is it clear? Yes. What are systematic errors? Systematic errors are those errors which always occur in the same direction, and sometimes by same amount while measuring particular physical quantity. Yes. What does it mean, same direction? Suppose I am measuring the length of this line AB. As we all know, any physical quantity which we are measuring will definitely have an actual value, isn't it? Let the actual value or actual length of this particular line AB be 20 centimeter. Let it be 20 centimeter. Now I am measuring using an instrument. I am measuring the length of the line AB, and I got values as 19.1, 19.6, 19. I repeated the same experiment for some 5 to 6 times, and I got all the values like this: 19.1, 19.6, 19.5, 19 and 18. Yes. So here we can see that all these values, all the measurements I got here are less than 20 centimeter. Isn't all the values I got here or all the measurements I got here are less than 20 centimeter. Yes. Again, suppose I am using another instrument for measuring the length of AB some 5 to 6 times, and I got the values as 20.2, 20.1, 20.9, 21, 22. Yes. Here in the second case I got all the measurements greater than the actual value. Yes. And I used one more instrument for measuring the length of this line, and I got the values at 19.8, 19.6, 20.1, 20.3, 21. Yes, I got values like this. Yes. Here we can see that all the values are less than the actual value. Here in the second case we can see that all the values are greater than the actual value, and in the third case we can see some of the values are greater than the actual value and some other values are lesser than the actual value. Yes. Now let's find the difference, or now let's find the error in each measurement. Yes. What is the error in the first measurement? It is minus. How do we find the error of a measurement? Yes, measured value minus actual length, isn't it? Measured value minus actual length. Yes. So the error in the first measurement 19.1 is minus 0.9. Second one is minus 0.4, minus 0.5, minus 1, minus 2. Yes. Here we can see all the errors occurred are in negative direction, isn't it? All the errors occurred here are in negative direction. Yes. Here in the second case, the errors are plus 2, plus 1, not plus 2, plus 0.2, plus 0.1 plus 0.9 plus 1 plus 2. Here in the second case, all the errors occurred are in positive direction, that is greater than 0. Here all the errors occurred are in negative direction, that is less than 0. Yes. Let's see. In the third case, minus 0.2, minus 0.4, plus 0.1, plus 0.3, plus 1. In the third case, some of the values are in the negative direction and some other values are in positive direction, that is some are less than 0 and some are greater than 0. I am saying these two in the first two cases, yes, all the errors which we got are systematic errors. I am saying you in the first two cases, the errors occurred are systematic errors. But why? Yes, here we can see all the errors occurred are in the same direction. In the first case it is in the negative direction and in the second case it is in the positive direction. But when you analyze the third case, you can see some of the error values are in positive direction and some other error values are in negative direction. So we cannot say all the errors are in the same direction. So if and only if the error arising are all the errors arising are in the same direction, we can say such errors in the measurements. Such errors in the measurement are systematic errors. Is it clear? Yes. So when do systematic error occur? There are so many situations or so many cases when systematic error arises. So let's discuss some 2-3 examples. Suppose I am using an instrument, which is not designed perfectly, or which is not properly calibrated. So what does it mean, calibration of an instrument? Calibration of an instrument is nothing but it is actually checking the accuracy of the instrument or how accurate the particular instrument can measure the physical quantity. So I am measuring a physical quantity using an imperfectly designed instrument or improperly calibrated or not properly calibrated instrument. Definitely in such situations we know errors occur, isn't it? Yes. We know the problem here. The problem here is with the instrument, and the issue of the instrument is always constant. The problem or the issue of the instrument is always constant. So we can say obviously the errors arising because of the usage of such instruments, we can say the errors arising will always be in the same direction, either greater than 0 or either less than 0. And sometimes we can say the error values might be one and the same also sometimes. Yes, this is one situation. The next situation is, we can say, zero error. Suppose we are doing experiments in electronics. In electronics experiments, yes, we use voltmeters, ammeters, etc. like devices for calculating the current value or voltage value, etc. Sometimes the needles of these instruments fail to return to zero when there is no voltage supply or when there is no current flow. Yes, in such situations, zero errors occur. That is, let's try to understand it through an example. Yes, here I am using an ammeter for measuring the current flow in a circuit. Yes, we use ammeters for measuring current flow and voltmeters for measuring voltage. Here I am using an ammeter to measure the current flow in a circuit, and I got some value as plus 3 ampere. Yes, now I switched off the power supply. And I noticed that, we know when there is no power supply, we can say the current flow in the circuit, the current in the circuit will be 0, isn't it? Yes. But this ammeter, the needle of this particular ammeter failed to return to 0 when I switched off the power supply. Yes, it is still, the needle is still pointing to plus 3 ammeter. Yes. Then I switched on the power supply. Yes, and I started doing my experiment. all the measurements, all the current values, all the current flow values which I get, all the current flow values which I get after this will be greater by some 3 ampere than the actual measurement. That is, if I am getting the current flow value or current value in the circuit as 5 ampere, yes. What does it mean? It means actually the measurement is 2 ampere. Actually the measurement is 2 ampere. If the needle was pointing to 0 initially, as usual, yes, we would have got a value as 2 ampere. But in this particular situation, instead of pointing to 0, the needle was pointing to 3. Isn't it? Instead of pointing to 0, the needle was pointing to 3. That's why we got the value as 5 ampere. So how do we find the actual measurement? 5 ampere minus 3 ampere, that is equal to 2 ampere. Is it clear? These kinds of errors are known as zero errors, and we can say all the errors arising in such measurements will be in the same direction, that is either greater than 0 or less than 0. Suppose I am getting the current flow value here. In the previous example, I got the current flow value as plus 3 ampere. Suppose if I got minus 3 ampere means, then yes, what is the current flow value? What is the actual current flow value? What is the actual current flow measurement? If I get the value as 5 ampere? Yes, the actual current flow value is 5 ampere minus of 3 ampere, isn't it? So we will get 8 ampere. So the actual measurement or the actual current flow value is 8 ampere. Is it clear, guys? Yes, if the needle was pointing to 0, yes, we would have got a value as 8 ampere. Here it was pointing, instead of pointing to 0, it was pointing to minus 3. So only we got the value as 5 ampere. So what is the actual measurement? What is the actual current flow measurement? It is nothing but 8 ampere. Is it clear? Yes. So in such cases of zero errors, we can say all the errors arising there are systematic error. Yes. And the last example is suppose there are imperfections. Suppose there are imperfections in the experimental setup. We can say in most of such situations, in most of such cases, we can say systematic errors occur. Say for example, I have to find the distance between two objects. A1 and A2. A1 and A2, and these two objects are to be placed at points C and D. Yes. If suppose instead of placing the first object A1 at C, I placed the object at some other point B. Yes. In this situation, we can say all the values we get while measuring the distance between these two objects, all the values that we get while measuring the distance between these two objects will be less than the actual value, isn't it? If suppose instead of placing at C, I placed the object A1, at some point F, like this. Yes, some point F, like this. In this situation, or in this case, we can say all the values that we get while measuring the distance between these two objects will be greater than the actual value, isn't it? Yes, either lesser or greater. Even if it is lesser or even if it is greater, yes, all the values will be in the same direction. So if the values obtained are greater than the actual distance, we can say errors occur in the positive direction. If the values are less than the actual measurement or less than the actual distance, we can say the errors occur in the negative direction. Anyway, in such situations, systematic errors occur. Is it clear, guys? Yes. So that's all about systematic errors. Yes, from entrance examination point of view, yes, you could hardly find questions from the types of error such as systematic error, random error or least count error. In most of the cases in entrance examinations, they usually ask questions based on precision, accuracy, or errors, absolute errors, relative error, combination of errors, etc. We could hardly find questions from types of error. Yes, but anyway, yes, we should know each and every topic discussed in the NCERT textbook, isn't it? Yes. So the next one, so the next type of error is random error. As the name implies, yes, these errors occur randomly. That is, some of the errors will be in the positive direction and some other errors will be in the negative direction in the same experiment. Not like systematic errors where always the errors occurring will be in the same direction. And to an extent we can avoid systematic errors. To an extent, if the instrument is properly calibrated, or if there is no zero error, or if the experimental setup is made proper, then we can avoid systematic error. But we couldn't avoid random errors, because random errors generally occur because of unexpected issues like fluctuations in voltage. Yes, if there are fluctuations in voltage while doing experiments, yes, we cannot avoid it, isn't it? Likewise, fluctuations in temperature. If there are fluctuations while doing experiments where temperature measurements are needed, yes, we cannot avoid such situations. So random errors are something which we couldn't be avoided while doing experiments, but systematic errors can be avoided to an extent. Is it clear, guys? Yes. The next one is least count error. Yes. So what is known as least count? Least count is the we can say least count is the minimum value. It is the minimum value or minimum measurement that can be measured using an instrument. Say for example, the meter scale which we are using, isn't it? The meter scale which we are using, yes, 15 centimeter meter scale. We are generally using a small scale which has a length of, or which can be used for measuring a maximum length of 15 centimeters. So what is the minimum measurement? Yes, we can measure using that particular instrument. We can say it is 1 millimeter, isn't it? It is 1 millimeter. How come? Let's see. This is 0 and this is 1. Yes, we know there are 10 divisions. We know there are 10 divisions between two adjacent values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. There are 10 divisions between two adjacent values. Yes. So what is the measure? What is the measure of a single division? We know 0 to 1 the length is 1 centimeter. 0 to 1 the length is, or between two adjacent values, the length between two adjacent values is 1 centimeter. And there are 10 divisions. We know 1 centimeter is equal to the length of 10 divisions, isn't it? Between two adjacent values, we have 10 divisions, and the length between two adjacent values is 1 centimeter. So we can say 1 centimeter is equal to length of 10 divisions, isn't it? Length of 10 division. So what is the length of one division? It is nothing but 1 centimeter divided by 10, that is equal to 0.1 centimeter. That is equal to 0.1 centimeter. What is 0.1 centimeter is equal to? We know it is equal to 1 millimeter, isn't it? It is equal to 1 millimeter. So the minimum value that can be measured using the meter scale, the 15 centimeter meter scale that we are using is 1 millimeter. Is it clear? Yes. If suppose I am giving a wire, if suppose I am giving you a wire of 0.2 millimeter, yes, can you measure it exactly? Can you measure the length of that particular wire exactly using this instrument? No, we cannot measure the exact measurement or exact length of that particular wire, because the least count of this particular instrument is 1 millimeter. So we cannot measure the measurement, or we cannot measure the length 0.2 millimeter exactly. We could find only the range, that is the length of the wire lies between 0 and 1. The length of the line lies between, not 0, length of the line lies between 0 millimeter and 1 millimeter. We couldn't find, or we couldn't measure the exact length. Is it clear? Yes. So that is known as least count. That is known as least count. What is least count? Least count is the minimum value that can be measured exactly, using an instrument is known as least count. So what are least count errors? Yes, let's try to understand it through an example. Yes, I told you one example just now. No, I am giving you a wire of 0.2 millimeter length, and I gave you a meter scale having a least count 1 millimeter. The length of the wire is 0.2 millimeter, and I gave you a scale or instrument whose least count is 1 millimeter. I asked you to find the length of this particular wire whose length is 0.2 millimeter. Can you find the exact measurement in such situation? Can you find the exact measurement? Yes, we could not find the exact. No, we could not find the exact measurement. We could find only the range of the length. It lies somewhere in between 0 millimeter and 1 millimeter, because the least count of this particular instrument is 1 millimeter. If suppose I am giving you another instrument, whose least count is some 1 mu meter, whose least count is 1 mu meter, and I gave you a wire of length 0.2 millimeter. I gave you a wire of length 0.2 millimeter. Yes, can you measure the exact length? Can you measure the exact length of the wire? Yes, in such situation you can measure the exact length of the wire, because yes, the least count of the instrument now provided is 1 mu meter, isn't it? Yes. So the division, or the measure of the single division is 1 mu meter, or we can say the minimum value which we can measure. The minimum value which you can measure using this particular instrument is 1 mu meter. So in such case, or if you are measuring the length of a wire having 0.2 millimeter using an instrument whose least count is 1 mu meter, in such case, yes, you can find the exact measurement. So in such situations where we are using an instrument whose least count is greater than the physical quantity, yes, the errors arising in such situations are known as least count errors. And also, just like systematic errors, least count errors can also be avoided to a certain extent by using the instrument having perfect least count. By using the instrument having the required least count or the perfect least count. Is it clear, guys? Types of error. There are 3 types of error: systematic error, random error, and least count error. Yes, let's see a quick recap. Yes, what are systematic errors? Systematic errors are those errors which arise or which occur always in the same direction, isn't it? Yes, and sometimes by same amount while measuring a physical quantity in an experiment. Systematic error occur in situations where we use instruments which are not perfectly designed or which are not perfectly calibrated, or instruments in such instruments in which the needle failed to return to 0, or we can say if the experimental setup is not proper. In such situations, systematic error occur. And in random errors are those errors which occur randomly. Yes, here the errors can be in either direction. Yes, it will always be in the, it will not be always in the same direction. Some of the values can be in positive, some other values can be in negative. Yes, and random errors occur because of some unexpected issues like fluctuations in voltage or fluctuations in temperature, etc. Yes, and the last one is least count error. Least count is the minimum value. Least count is the minimum value that can be measured using an instrument. If we fail to use the instrument having required least count for measuring some physical quantity, yes, in such situations least count occurs. Is it clear? Yes.